Okay, if you guys go to AP Central, let's just see. Okay, you're gonna go here and they're gonna say, oh, learn how we're supporting schools. I want you guys to click on that. Okay, so there's a couple things that's going on that are new, and I'd like to let you know. They are giving free remote learning resources. You can click here and you can get info on them. All right, so here are some of the resources. Computer Science A. They're having some sessions that are live. I'm not really certain where the links are. I looked through a couple times and I couldn't find them. I'm assuming that they're going to come out soon or that I've just missed them. So you guys may be able to have a better view of that, or you may be able to better find that. These are on Unit 9, which we're on right now. It's on the part that we just finished about creating subclasses and superclasses. So I wanted to show you that. I also want to talk about some changes that the tests are going to have. So the changes in the tests are this. It's likely that you guys will have a 45-minute online free response exam at home. Okay, you're going to be able to take that through a couple of different ways. Okay, so they want to do different types of like I don't know if cell phone's on there, but I think they want to have it with a tablet or a computer. I don't know if because this is AP Computer Science class, they may have us have a computer, but I did want to point out this section here. See, it says they'll take them on exams on any device they have access to, computer, tablet, or smartphone. Okay. So it looks like this is how it's going to work this year. It's just going to be free response. They're going to they want to know if you have some sort of like low income or rural students. So anybody who is having a hardship, if you need to reach out to them, please do. It's right here. Or let me know and I can do that as well for you. I'm going to go down here to Computer Science A and show you kind of the what's new, I guess. They are testing only on units 1 through 7. 8 through 10 are not being tested. There's lots of unknowns here. So besides the fact that it's going to be a free response question, they don't really tell what type of question it's going to be. They don't tell when the exam date 1 is. They don't tell when the exam date 2 is. So these are all kind of things that are up in the air, but I did want you to be aware that they're only testing up through, I believe, array lists. So 2D arrays aren't going to be covered, and neither is polymorphism and neither is recursion. Now that said, I do think inheritance and inheritance and polymorphism are important. We've already finished half the lesson, so I am going to finish the last half of the lesson. I have not decided whether or not we will test on it. I also have not decided whether or not, or how our final is going to look, or even if I can give a final remotely, or maybe we'll be back in school by then. So all this stuff is kind of up in the air. I will let you know as I find things out. I'm finding that like planning way in advance is getting harder because things are changing. So that said, I did want to let you know kind of what things are looking like right now. Okay, so we're going to look at polymorphism. Let's start at the beginning of the lesson. Now, again, this won't be on the test, but it's actually pretty important, and I think it's one of the cool things about how Java works. It is something that I would think that you would really want to know if you are going into computer science. It's one of the main things of how this object-oriented programming kind of works. So when we talk about object-oriented programming, we talk about encapsulation. So who can access what? If it's public, anybody can access it. If it's private, only the members of the class can access it. And if it's protected, anything within the inheritance hierarchy can access it, but nowhere else can it be accessed. Now, inheritance, remember that's when we just talked about that. And we also talked about protected and private and public, but inheritance is using existing code by extending it with very few modifications. It makes things a little bit easier on us. Polymorphism, which is what we're going to talk about now, is basically that everyone every object knows how to handle itself, even if it's in its own disguise, which we'll talk about. Now, let's pretend we have a lot of different students. Let's assume that every student has a method called study, and that is specific to each student. Okay, we want to say that a college student is a student. Maybe the college student also drives to school. A high school student is a student. An elementary school student is a student. A kindergartner is an elementary school student. Maybe they also learn how to read. A PhD student is a college student. And maybe they also write a thesis. So here's our inheritance hierarchy with student being at the top. They have an ID num, an age, and a name. If this stuff is private, it's only accessed using a getter method, even within these classes. If it is public, you could access it anywhere, but I wouldn't want to do that. It's a little too much information out there. If it's protected, any of these classes could utilize it. Now, generally on the AP, they leave them as private, but since we don't have to worry about the AP, I would maybe make some of this stuff protected. Okay, we have a default for study and a default for eat because all students study and all students eat. So now, all students study different ways depending on what type of student they are. Elementary school student studies different than a high school student, studies different than a college student. A PhD student even studies differently than a college student, and a kindergartner definitely studies different than maybe, say, a fourth grader or a different elementary school student. We can have additional methods like drives to school, writes thesis, or learns to read, and even this other method called eat string place. I put that in there because I just remember that, like, when I went to college, I would eat at a lot of different places because I wanted to find out where my new town is. So that was something that was just new when I moved away. So in Java, and this is important, we can mix objects of different types. So I might have a student, Izzy, a new elementary student, but I'm going to call it, have the computer recognize it as a student at first. Okay, same thing, this could be a college student declared as a student. This could be a PhD student declared as a college student. Which comes where does matter. So we'll talk about that in a minute. They all have names. They all have IDs. They all have ages. Okay. So when we mix object types, there is a rule. A variable can be defined as a superclass. So this has to be the superclass. This has to be a subclass. You could go through the hierarchy. So if I were to go back the hierarchy, you could go from student and you could declare a student and assign as kindergartner. That's fine because this is a subclass of student. So you can cross through the hierarchy, but you just want to make sure that the superclass comes first. Where am I? Sorry about that. That the superclass comes first and then the subclass. Okay, so why do we do this and why is it useful? Lots of times we want to put objects that are related through inheritance into the same collection. We want to put them all in the same array. We want to put them all in the same array list. Okay, how is this possible? Well, it's possible because kindergartners and PhD students, here we see a new student. Okay, we're making a list of students, an array. Okay, of 2, we can have a kindergartner there and a PhD student in there because they're both students. So the computer sees them as students at compile time. Polymorphism is the mechanism of the computer selecting the appropriate method to use for a particular object in a class hierarchy. Okay, a polymorphic method is a method that has been overridden in at least one subclass. So what the computer does, for example, we saw, I'm going to go forward a couple. We saw that all the different types of students studied differently. So when I call study, different things are going to study different ways at runtime. Okay. And this happens, late binding happens at runtime. So it'll say, like, let's back it up here. It'll say, oh, this student at 0 is a kindergartner. If I say student at 0.study, I'm going to look in the kindergartner class and have that student study like a kindergartner. Because this one is a PhD student, students 1 at 1.study, it's going to look to the PhD student class and have it study like a PhD student. Okay. So now we have gone through two different things. We talked about this a little bit last lesson. We're going to kind of dive into it more. So we have things that are overridden versus things that are overloaded. So overridden things have the same name, the same parameter list, and the same return type. They have the same return type because if they feed into a different method, we want them all to kind of return the same thing so we don't come up with some strange sort of error. Okay? An overloaded method has the same name but a different parameter list. Doesn't matter what the return type is because the computer sees them as two completely different things. So here we have, here we have our students, and you can see they all study differently. The ones in red, because they all match our superclasses study, they're all overridden methods. Same name, same parameter type, and you can assume they have the same return type. Now, eat here is a completely different method. It's an overloaded method. Even though it's called eat, this one has a parameter string place, and this one doesn't have a parameter. So they're recognized in the computer at compile time as two completely different methods. Okay, so now we have what's called static binding versus dynamic binding. Static binding or early binding refers to the compiler's decision on which overloaded method to use. It's made during compile time. They see them as two completely different methods, so they can choose easily which method to use. Dynamic binding or late binding refers to Java's decision on which overridden method to use, and that happens during runtime, like we just talked about. So, let's say we are back to our list of two students, the kindergartner and the PhD student, Julie and Sam. Okay, so if I say students at 0.study, it's going to use the one in kindergartner. If I use students at 1.study, this is all during runtime, it'll use the one in PhD student. Now, if I try and say students at 0.write thesis, that's going to give me an error, which makes sense because kindergartners don't write theses. So it's going to give me an error. That method isn't inside that class. Makes sense. Okay. So when I talk about type compatibility, what methods do I have access to? Okay. So student Sally becomes a new PhD student, and PhD student Sam becomes a new PhD student. So this one is mixing types, probably to go into some sort of list. This one is not mixing types. At compile time, what happens? Well, at compile time, Sally gets an error. Sally.writes thesis gets an error, but Sam.writes thesis does not. Okay? The reason is because at compile time, the computer is seeing it as whatever it's declared as. So since student does not have a writes thesis, then I'm going to get an error. But here, since PhD student does have a writes thesis, I'm okay. So, like I said, Sally is a student, and a student does not have a writes thesis method, even though it is assigned as a PhD student. At compile time, the computer is seeing it as a student. So only the non-private methods of a student class can be called on Sally. Okay? The type at compile time is the superclass. The type at runtime is the subclass. Okay? So that means like when you're typing out your code, because I think it compiles as you go, that's what it's looking for at compile time. Okay? When we actually hit the play button and it runs, then it's seeing it as a PhD student. At compile time, the method must be found in the superclass. If it's not there, we have to do what's called downcasting, which we actually have already done, I believe. At runtime, the type PhD student, okay, and thus whatever the method is here should be used to determine that method, okay? Now, here's what I do to get around that. Here's my nice get around. Usually there's an if statement before, so we can say like, if Sally is I think there's a method in here that I'm not looking up right now, is a student, then we can call it, okay? This is called downcasting. I'm going to come back to that in a minute because my time's going to run out.